start sharing your screen anytime now.
Great. Let me just find my screen. That looks all right.
Yeah. And Ignacio, do you have the bio, or should I?
No, I can.
Yeah, go for it.
Thank you, everybody, for joining today. Today we have Dominic O'Brien, Professor of Engineering Science at Oxford, where he leads the optical communication groups, and he's also a director of the UK National Hub in Quantum Computing and Simulation. And today he's going to be telling us about the hub in all-spectrum connectivity. And with that, the room is yours.
Brilliant. First of all, can I check that the screen is sharing properly?
Yes, it is.
Good. That's fantastic. Well, thanks very much for having me. My name's Dominic O'Brien, and I'm at the University of Oxford, and I'm going to talk very briefly about the hub in all spectrum connectivity, our activities and our future plans, and I'm very happy to answer questions at the end. Let's just see if I'm moving. That's great. So our theme really is about this evolution of wired and wireless communications. So wireless is moving to higher frequencies. We've seen this spectrum drought that occurs down in the sort of low gigahertz regions of the RF spectrum. And as we move to higher frequencies, we tend to get shorter wireless links, and both because of the less good link budget, and also this increase in data rate means you need to get more energy on your receiver, so you tend to use shorter links. And that in turn has been leading to greater fiber infrastructure to connect the access points to those links. So you're ending up with this tree of fibers, which getting closer and closer to the end user with shorter and shorter wireless links. So if you see, for instance, the fiber to the home standard, it's becoming that they're starting to work on fiber to the room standards now, noting that kind of increase in the density of the tree. And talking to operators, talking to people, you need to consider both the fiber and wireless systems together. And that's really one of the main ideas behind the hub, that you can't just optimize one thinking the other is a bit delivery system. You need to think about them both together. And spectrum is a good way to think about them. Photonics is bringing quite a few new opportunities. The world of fibers is evolving as well as the world of RF. There are new hollow core fibers where actually you can get very wide propagation spectra with very low loss, all the way from down in the UV, early UV, all the way up to the mid IR in a single hollow core fiber with these really up to the minute fibers. The other interesting thing that's happened is that at least the first generation of quantum key distribution systems are becoming commercial. So that what they call prepare and measure QKD, you can buy boxes, which will do that. And there's a question of how you extend that modern security to wireless links as well. And of course, there's a sort of background quantum computing will at some point be able to factorize these large numbers, which mean that some of the asymmetric key encryption systems are no longer as secure as they might be. So you need to be thinking about that in the longer term also. And that's what this diagram on the right-hand side, let's see if I can get a pointer, kind of shows that you have this orange bit of wireless spectrum, that's the RF. Now it comes up into this optical wireless domain, which is becoming more and more current. There are standards in that now, so that's becoming a more mature area. And the fibers are in this green bit. And actually there's an interesting overlap where you can use light from the fiber. You don't even need an RF wireless interface either. So that's really the idea between an all spectrum connectivity hub. It's thinking about both the fibers and the wireless systems as a single whole. So here are our partners. We have 8 partners with 21 investigators. That's our core consortium that was funded originally. So up in the north, Strathclyde, optical wireless, Wi-Fi networks. Belfast, well-known wireless MIMO, RIS surfaces, those sorts of things, communications theory, security. Bristol, a very wide range of things, end-to-end, both quantum, both classical, wired, wireless, extensive expertise, and links into the socio-technical, also compound semiconductors. So a range of sort of allied technologies and allied thinking about how you might use such future networks. Ourselves at Oxford, really optical wireless free space, as I'll show you in a second, a bit about quantum computing as well. We've got domain knowledge in that area. Cambridge Quantum Comms, Photonics RF, Imperial, physical layer, AIML, and UCL terahertz free space optics, and Southampton a range in both fibers and wireless communications. So that's the original consortium that we have. So we've organized ourselves across 4 challenges that you see listed here, C0 to C3. And the diagram on the left really shows how we've thought about this. So at the bottom, we've got this wireless spectrum running all the way through from RF to light in terms of frequencies. And then a wired spectrum. Now, of course, these days, that's actually optical as well, because it's optical fibers running all the way out from the 400 nanometers, the world sort of at the end of the UV, all the way out to the IR with modern fibers, or the latest generation of fibers. Now, the interface between the wired and the wireless is going to have some agile interface, so we're thinking about that. It's also, there'll be elements where you don't actually need any conversion at all. As I said, you can use the light that the fiber systems create, and I'll show you an example of that. So that's the sort of connectivity elements of it. It's really about thinking about how you might connect these different media in an optimal kind of a way. Then there's this adaptivity, which is, okay, so you can connect them. Which ones should you connect? How do you adapt? How do you dynamically change as the environment changes? The third challenge is one of security, looking at, as I said, bringing on these more modern security ideas, post-quantum, physical layer security, QKD, and see how that plays into this joint domain of wired and wireless systems. And that's underpinned really by this modeling activity. Now, that's not a sort of wheel reinvention of the extensive amounts of modeling that have been done in both the optical and the RF domains. It's really trying to build a comparative system level model that takes all of this modeling and puts it on the same basis so that we can actually understand a particular situation to a degree that you can decide what is an optimal set of connectivities that you might use. So that's the sort of overview. On the modeling, just a bit more detail about each of those elements, really thinking about KPI use cases. And as I said, this combination of system level modeling. We may do some measurements as well to try and validate some of the modeling that we do, but the broad idea is to try and actually bring together the work that exists in this area at the moment. And then comparative analysis of using some of these more modern, if you like, propagation engineering ideas like RIS across both optical and RF domains, looking at MIMO and seeing how that plays into this as well. And of course, considering different environments. The spectrum connectivity is really about thinking about demonstrations that bring together different elements of wired and wireless across this spectrum. Optical wireless is one of these new fiber wavelengths, terahertz, sub-terahertz bands, thinking about those. And then also this agile interface, how we can build the sort of interfaces and RAN aspects of it as well. Things like frequency conversion. If you think of it in a spectral idea, you've got some fiber frequencies that you want to convert to some RF frequencies, those sorts of ideas. And demonstration interfaces and technical requirements. Then in the adaptivity, it's really about the sort of resource management of the spectrum and the sort of interference management in more concentrated environments and mobility management, all those sorts of aspects. And I think this is underpinned by this modeling activity so that the model will allow you to look at the effects of adaptation, things like that. So it's they all plug together to give us this overall picture. And finally, security, really, as I said, QKD combining fiber and wireless and seeing where QKD can help, or that combination of optical and RF might be interesting. Now, QKD, you can really only do with light. So, you're restricted in how you create wireless channels using QKD anyway. But that restriction actually might give some security advantage, I think. Then physical layer security, again, the sort of confined nature of light might offer you greater protection in terms of physical layer security. And then some work on post-quantum encryption and how that might feed into these digital systems. And clearly that's a massive topic. And so I think here it's really rather specific about how that's going to play in a communications network. So, of course, we do both research, and I've talked a little bit about that. I'll show you some snapshots in a little while of particular work within the hub. We also have an engagement activity, and part of that will be open calls to expand the hubs. When the All Spectrum Hub was funded, we left about a quarter of the original funding uncommitted deliberately so that we could have open calls to bring on new partners that could add to the mission of the hub, if you like. And so we're working on timelines, et cetera, for that. And actually, as within this structure that's being worked on of the three hubs coming together, that part of that is also this expanding the community goal as well. Workshops and industry engagement. At the moment, we've actually just been working between the three hubs because of our other activities, wanting to get the plan sorted out. But we'll be opening up workshops to a much broader community in the near future, I hope. And then the other part is this joint work between ourselves and the Titan and the Cheddar hubs. And I'll talk about that just to finish off. But I thought I'd just show you some snapshots of some real stuff rather than the sort of overview. So Imperial are a physical layer group, and that's Kinley Young and Bruno Clerks in their group there, and they've been looking at physical layer optimization, looking at risks, all of those sorts of things, modulation schemes, and ML and optimization. So there's a lot of, you might imagine, there's a lot of AI ML across all of the three hubs in terms of an underlying mechanism for optimization and some work on physical layer security. This is work from UCL on terahertz, and this is a terahertz link that you can see in the photograph. The terahertz is made there by mixing two optical signals on a photodiode, so it's a beating process that gets you the terahertz, and that's nice because it's fiber compatible. You can build the optical signals in an optical fiber, those sorts of things, and that's reconfigurable up to 330 gigahertz. UCL also work on free space. So this is some work they do on emulating what it would be a ground to LEO satellite link. Now, in the world of satellites, these LEO constellations, there's a reasonably rapid shift, as far as I can tell, to optical links between the satellites for the space network. But of course, the ground to satellite will be a great thing to have. That's much more challenging because of the turbulence in the atmosphere. And this is a simulation of that to see what the effects of that might be. The other aspect that UCL are involved in is their lead, and I don't know if you guys use this, or they lead the National Dark Fiber Facility, the NDFF. And there's a picture of it there, and within that facility there's both dark fiber and there's some layer 2 connectivity as well, and some of the links you can see on that are dark fiber and some of them are layer 2 connectivity. And as part of I'll mention it briefly later, as part of the Federation of Hubs, there's work on a sort of greater set of connective infrastructure than NDFF, and NDFF sort of plays into that as well. But that's quite an important part of the hub gives us access to those sorts of facilities, or you know, UCL, having UCL in makes it very valuable. So this is work from my group at Oxford, and what we have been doing for some while is doing very short wireless links with just fiber to fiber. So you take light from a fiber and you steer it somehow to another fiber, and that means you leverage all the technologies that fiber gives you. And it has all the disadvantages of a high frequency RF link in that it's very narrow field of view. You have to point it, you have to track it, all of those things. But there's no interface. You're just literally using light from the fiber. And this is work we did with our collaborators at Bristol, which takes a 1.6 terabit per second fiber signal and combines it with a QKD signal and sends it into free space. So if you like, this is wireless and wireless QKD together, albeit very experimental, I have to say. So just a bit more detail on this here. If you look, I'm not going to go to it in fantastic detail. There's a WDM system here producing a classical signal here. There's a commercial QKD transmitter. They're combined. They go through free space using our system back into Bristol system, and they're separated again. And it's quite straightforward to separate them using the conventional components you might have. And the other bit of QKD is again with Bristol, a different group at Bristol that we do, is looking at very short range QKD. So this is almost like a mobile phone to a mobile phone QKD link. Here we've got a handheld device that sends a QKD signal to the box you can see on the left-hand side, and that's a QKD receiver. Now, the sort of difficulty is that your hand moves around and you have to do a load of tracking so that it tracks, the beam will track properly. So this handheld, you point at the box and the box compensates for the hand wobble, and you can actually get QKD transmission. So the QKD is interesting because I think it's about how do you combine what is a wired QKD system and take it out to wireless terminals, and what might be the benefit of doing so. And I think those are interesting questions. And security, of course, is going to be a massive issue as wireless systems evolve and we start to see quantum computers of size and reliability become real. So this is work from Cambridge, and they're looking at using particular sorts of laser to do beam steering. Again, these are narrow links for the optical wireless to achieve high rates. Top right, you see a couple of pictures of the lasers. They've got different contacts on different parts of the laser. And because of that, they will allow you to change the current injection into the device, which will give you some sort of steering. And this is what the graphs at the bottom show. They're also radio access people. So here's a picture of a tree, if you like, of all the work they've done in that particular area, looking at front haul. So for instance, using free space optics and front haul together, hybrid front haul spectrum sharing, and some compression and resource allocation. So a range of things across that sort of physical layer and providing data to the radio network. Oops, wrong way. This is work from Strathclyde, and they're working on optical wireless as well, looking at very high density, high speed, so terabit per second, using dense arrays of lasers effectively to provide very small cells within a room. Each laser provides very high data rate via this transmitting element in the ceiling and creating rather small cells on the floor. And of course, that's a benefit of doing things optically. You can create very dense systems. Oops, sorry, again, wrong button. They also do some work on FSO, and these are demonstration links, a range of things. Interestingly, using solar cells, solar panels as receivers is an interesting possibility of adding RF on, or sorry, optical wireless onto other functions, and trying to get towards a gigabit per second with those systems. So really impressive results for that sort of work. Okay, so that's a set of snapshots given time. I haven't shown by any means all the work that's going on within the hub. I thought I'd finish with a couple of slides talking about how the hubs are coming together as a sort of federated hub, which was part of the original plan in the call that EPSRC had. So there are 3 hubs which were funded. So ours is in the middle, and really, as I said, that's sitting at the physical layer, bit delivery end of the picture. if you like. And there's a network of networks hub that's called Titan, and that's run by Harold HASC in Strathclyde, or led by Harold HASC in Strathclyde, I should say. And that's about how do you start connecting these networks in a seamless way to create the end-to-end services and end-to-end delivery that we all want. Then there's Cheddar, and I believe Julie has presented to this forum already, so it's run by Julie McCann at Imperial, and that's really about the sort of edge, the fog, cloud computation. And so if you like, the three of them together sort of represent the whole stack, from end applications through to how the networks come together, and at the bottom, how you deliver the information across the channels as well. And if you look at the bottom of this diagram, there's a whole load of common themes. So the RF engineering sits mostly in all Spectrum and Titan, and then there's quantum, the emerging sorts of technologies sit a little bit across both several of the hubs, things like spectrum innovation, and all of the metrics that we imagine: energy efficiency, resilience, security, those sorts of things, sitting between the three hubs. So this is my last slide. Where we are at the moment, we've worked quite closely with the other hubs. All the hubs are working together. We had a joint workshop in June looking at our partner expertise and common themes. I think there are probably 70 or 80 investigators across, probably more than that, across all the three hubs. We've also been working closely with EPSRC and DSET to plan activities, including infrastructure to provide connectivity, and then community building through open calls, workshops, those sorts of things. And that's acting as a federation between the three of us, and industry engagement. And there's a limited, because that work is underway still, the final results of all the work that we've been doing aren't really kind of out of the door yet. So there's a limited amount. That's why this slide's rather limited. But we're hoping in the near future there'll be a lot more that we can say about sort of the open calls, those sorts of things. I'll leave it there. Thanks very much for giving me the opportunity to chat. Very happy to answer questions as best I can. Thank you.
Thanks, Dominic. That was really helpful. Any questions from anyone? I had so I do quite a bit of work on satellite, LEO satellite stuff. So I was kind of interested to hear that that's also part of your picture, and especially the ground to space. People are talking about optical, but I guess weather is going to be an issue there. Ground weather, not space weather. And I don't know if you had any more details that you could share about that part. That would be interesting.
Well, okay, so in terms of the detail of what we're doing in the hub, that's probably about, I can put you in touch with UCL, and they would be best to answer the technical detail. In terms of the more general challenge of ground to satellite optical comms, there's been work that says something like, depending on where you pop your ground stations, NASA have done a fair amount of work on clouds and stuff, and looking at cloud maps of the world and going, okay, 5 good places will get you a link always, kind of thing. And my memory is the number varies depending on where you do the analysis, between about 3 and 5 ground stations. If you give yourself global freedom, we'll get you a link. The real challenge is, I teach a little bit on a ESA course where they're interested in this. The real challenge, I believe, it's ground to space, because the turbulent layer is just at the bottom. And where they're looking at, I think, is adaptive optics. And it's a bit like telescope systems, the big telescopes that we're doing in Chile and places like that, except my understanding is it's more complicated because of the look ahead of the satellite, that if you did simple adaptive optics, you'd be using a guide star in the way that you might with light coming down. You'd be correcting for the wrong plane by the time you pointed the beam towards the satellite. So I think it's really hard to do the uplink. But I know
Right.
that there's an awful, people like ESA and stuff are doing a fair amount of work, because it would be great if you could. The downlink, I think, is more tractable because the turbulence is right at the bottom.
Right,
So,
got it. Yeah, fascinating stuff. Any other questions from anyone else?
Yeah, maybe I had one that probably goes into the territory, Dominic, I'm afraid that you don't know, which is how do you plan to orchestrate the works with the other hubs, and whether you will create, I don't know, like some sort of umbrella structure on top of it, or it will be done more in a case by case.
I think that the plan is that we some umbrella structure, and of course, bringing together expertise from under these common themes, if you like. So you know, trying to attack a particular theme, but having the expertise from veins. I mean, it seems to me that's the logical way to do it, and I think that's the plan.
And do you know also in the long term, what are the plans of EPSRC, UKRI with regards to the hubs? Do they have a long-term vision, or?
Well, I think the idea is that the hubs will be okay, so stepping back a bit, the history of this is that the quantum hubs have been running for a decade almost now, and they're seen, my understanding is they're seen as a decent success and a way to do it, because they've been a point of people coalescing as the community. And so I don't think EPSRC funded these things thinking they were going to be short-term things. Now, of course, how they evolve, you know, where the hubs are and what they do, but this idea of a hub as the center of as a means for a community to come together, I think is something they like. So I don't think it's a short-term plan, but I think there's a sort of, I don't know the best way to put this, you know, that balance of long-term aspiration and short-term practicality, I think is always one that takes some squaring.
Yeah, fair enough. Thank you.
Anyone else?
I can ask one if you want.
Yeah, go for it.
So thanks, Dominic. That was very interesting talk and a set of themes. From the point of view, we or I certainly look at this as a sort of end-to-end point of view, or if not end-to-end, a sort of multi-hop point of view, and how you develop services over these advanced networks. So you mentioned that you've got NOAA in your consortium, and obviously the Bristol team that does networks quite a bit. Do you have any examples maybe of work on architectures or services that you will try to develop as examples maybe on top of your networks?
I think that is something that is part of planning at the moment, you know, in the sense of we had our first joint hubs workshop in June to bring together and just understand expertise and things like that. But I think that I don't know what the plan is at the moment but I think the plan is to have particular themes and particular goals which will allow us to bring together a range of expertise to create exactly the end-to-end. And I guess part of the community building, the open workshops and stuff will be about what do we believe are those demonstration cases which we should focus on. So I don't know what they are at the moment, but I think you're right, we need to have some, and it's in the plan to get some.
Excellent. Yeah, that'd be interesting to know this. I suppose Titan, we haven't heard from Titan yet, but suppose Titan will try and manage the switching between domains, right? But yeah, from a spectrum point of view, it would also be interesting to see this.
Yeah, I think I mean, you know, you divide this problem into three. There are 3 funded hubs, but there's a massive amount of overlap between them in terms of, you know, that network to network switching. It's problem that spans everything, all aspects really.
Thank you.
Maybe one final question
Sure.
from people on the floor, if there's anyone. If not, I had one curiosity question about when these calls that you said for open calls for additional projects and getting partners and so forth. When do you expect it to happen? And is it like multiple tranches?
So I can tell you what we planned within our hub was multiple tranches. But that was the original plan, and I think it's evolved slightly with discussions with EPSRC and DSIT. So I suspect there'll be. My feeling is that in terms of timing, probably the next few months we need to be doing something, and then what comes after that is less clear, I think, in terms of the span of the original hub. The original thing was a 3-year span, and I think we'd planned several across year 1, year 2, those sorts of things. I think it depends a little bit on what demand is and how things.
Yeah,
we can respond somewhat dynamically, I think, to what actually it looks like the demand is and what is sensible to do.
That's okay. So yeah, just keep us in the loop, and we can.
Oh,
send
absolutely,
it to MG,
absolutely. We'll be, we'll be, whatever we do, we'll be making sure that we keep people informed and communicate. And in fact, it's nice to know this forum is here, and we can. It's now a familiar path for us.
Indeed, yeah. All right. If there are no further questions, then thank you so much. That was a fantastic.
It's a pleasure.
And
Thank you very much indeed.
Other work that they have been doing.
Okay.
Yeah.
Bye now. Bye everybody.
Thank you.
Bye for now. Bye.
Bye.